Here we are with the final unit in the Object-Oriented Programming Introduction. One thing you may have wondered is, how are these methods called? And by how are the methods called, I mean which method is Matlab deciding to call? Many of the classes have identically named methods. Doubles have a plus method, year E7 objects have a plus method, and date E7 objects have a plus method. In an expression that involves plus, how does Matlab decide which method to call? That's what this unit is all about. Before we get to that, let's see how methods are called. There's two manners to call a method: function syntax, which we're very familiar with, as well as dot notation syntax, which we haven't talked about and we'll cover at the bottom of this slide. Let's talk about function syntax. If object X is from a user-defined class, let's say class X, and A2, A3, A4, and so on are some built-in Matlab classes, double, char, cell, struct, then this function syntax, y equals some method, open parentheses, and then the argument list, will call the method as expected, passing the input arguments in the usual fashion. Object X is the first input argument, A2 is the second, A3 is the third, and so on. But what if A2, A3, and A4 are not objects from the built-in Matlab classes? What if they're from other user-defined classes? How does the class of these arguments affect this dispatching? It turns out, in fact, it does complicate matters, and that's what we'll go over. Now, what about the dot notation syntax? Here's effectively an equivalent version of what's above in dot notation. First, the object is listed, then a dot, and then the method name, and then the remaining arguments from the argument list. Notice that obj is not an argument, at least in this call. It's out in front. This is equivalent most of the time, but generally it has some simpler rules for dispatching, and those simple rules might be what you're looking for, or they might not be rich enough. It depends on the class. Right now, I want to go over just how it all works and what are the rules. Let's talk about the function syntax. Let's suppose A, B, and C are objects of different classes, and consider this expression some method ABC. Let's assume that MATLAB's already determined that some method is not a variable in the current workspace, and it knows it's looking for a function or a method. So, which method will be called? A method drawn from class A, a method drawn from the class of B, a method drawn from the class of C, or a method from some other class, or just a function in the Matlab path not associated with classes? The answer, look at this help entry determining which method is invoked. No reason to read the words, that's what we're going to do now. And question number 2, how is the dot syntax method equivalent to the function syntax method? Let's address question 1 first. Which method will be called? So remember, we're focused on this expression, and MATLAB has already determined that some method is not a variable in the current workspace. So what is the search order? From within a function, is some method a visible subfunction? In other words, a function in the same file. Is it a visible private function? Or, and this is really what we're focusing on this slide, let's assume 1 and 2 are not what's happening. Is it a class method or a normal function on the MATLAB path? Specifically, we have to define what's called the dominant argument and the class which is called the dominant class. The definition is the leftmost argument, this is from A, B, and C, that is not inferior to any of the other argument classes is called the dominant argument, and its class is called the dominant class. Once the dominant class has been established for the argument list A, B, C, the method, some method from the dominant class is called. If no method exists, then the MATLAB path is searched for a function of that name, and if no function is found on the path, there's an error stating that the function call involved an unknown method. We've all probably had that happen on more than one occasion. There's a new concept we've introduced here, the notion of classes being inferior to one another. Let's talk about that. First, all user-defined classes, by default, have higher precedence than all of the MATLAB built-in classes. To put it another way, all of double, cell, char, struct are inferior to all user-defined classes, including, for instance, year E7 and date E7. This gives most of the solution in answering the question we posed at the beginning of this unit. How is the correct method called? Let's take this example, adding a date E7 object to an integer. Of course, that calls the plus method. I've shortened them to object1 is the date E7 object, and object2 is the integer double. Let's read the rule. The leftmost argument that is not inferior to any of the argument classes, let's work from the left, is the date E7 object inferior to any of the arguments in the list, in this case the single other argument, the double? And the answer is no. Therefore, it's the dominant class. Therefore, the plus method from the date E7 class is called. By default, all user-defined classes are of equal precedence. What this means is that year E7 objects are not inferior to date E7 objects, as well as the converse. Date E7 objects are not inferior to year E7 objects. Using the class attribute, inferior classes, you can define precedence, in other words, inferiority, among user-defined classes. We'll see how to do that on the next slide, although in this course we won't have an opportunity to use this much. As I just mentioned, there's a class attribute called inferior classes, and in the class def file, use a cell array to specify which other classes are inferior to the class being defined. For an example, let's suppose that class S is defining that class I should be inferior, and that's done using the following syntax. Here's the class S class def file, and it's right here, this line in the middle. It's an attribute of the class, and the inferior classes are a cell array of all the classes that should be considered inferior to this particular class, class S. The question mark is a metaclass operator, and put in front of a class name creates what can be thought of almost as an empty instance of the class I, but it is able to identify itself as class I. Therefore, this list of metaclasses is the way to specify the inferior classes to class S. Let's close this unit, returning back to the dot syntax, which we didn't get a chance to talk about. Remember, the dot notion syntax appears like this. The first argument is moved out in front, preceding the function name with a period, and then the remaining arguments stay in the conventional argument list. It turns out that the dispatching for this is actually very simple. This always calls the method from the class of objects, and the input argument list will be the first object and then the remaining input arguments. So here, in contrast to the function syntax, the classes of the remaining arguments do not have any influence on the dispatch. You may have also heard the term inheritance. That's a separate idea, distinct from precedence, about relationships between different classes. And it's a component of most object-oriented languages. We won't have a chance to cover that here. We're only doing one lecture on object-oriented programming. It just goes to show you there's always more to learn. Now it's time to move on to the homework on object-oriented programming. Good luck.